Today we're going to be working on Leetcode question number 273, integer to English words. Convert a non-negative integer num to its English words representation. So the num is equal to 123, which is going to be 123. This number is going to be 12,345, and this one is 1,230. 4,567. So in this class we're going to be declaring few like the hard-coded values. These are the this is going to be like an array. So we're going to say private final string array. We're going to call it less than 20, which is gonna be an array having all the numbers below 20, which is nothing, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we're gonna go all the way up to 20. Less than 20, so it's gonna be, we're just gonna keep it up to 19. Okay, 11, 12, 13, 14, 15, 16, 17, 18, and 19. And still we are not done yet, because we're gonna have two more of such variables. Now one for covering all the tens and one for covering all the thousands. So private final string, and for the tens we're just gonna call it tens, empty 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, the last one is for the thousand, and there's only three kind of thousands we're gonna cover as like it's gonna be less than a billion. So okay, so for that one we're gonna say private final string thousands, which is gonna be again an array with the first element as empty. The second one is gonna be thousand, then a million, and then a billion. That should be enough. Okay, once we have that, the logic is very simple. It's like if the num is equal to 0, we're gonna be saying that return 0, right? That is just a conditional, like if we are in that condition, we're going to be returning 0. We're going to initialize our I equals to 0, and we're going to initialize our answer word equals to an empty string. Once we initialize it, we're gonna keep looking at the number. While the number is greater than 0, we're gonna keep processing it. Otherwise, we're just gonna return the num word dot words. Let's just call it words dot trim. I should do it. Okay, and once we still have our number, like it is greater than 0, first thing we want to check if the number, if we take the modulus of the number by 1000, right? Uh, if that thing is not equal to 0, meaning if it is uh, like, all it means is like, if it is not like that, if we take the modulus by 1000 and the answer is not equal to 0, right? The answer is gonna be the answer is only gonna be 0 when uh, the answer is only gonna be 0 when the number is is gonna be less than 1000. If it is greater than 0, uh, all we need to do is like divide it by 1000 and just keep an eye on our I. We're gonna keep incrementing the I. So other than that, the only time we're gonna process it is when the number will become less than 1000, right? When you take the modulus, I'm sorry, when the number modulus doesn't mean that if it is not equal to 0, doesn't mean that uh, like it does not mean that it is less than 1000 or greater than 1000. All it means is it's not completely divisible by 1000. So if it is completely divisible, if it becomes equal to 0, right? That means if it is completely divisible by 1000, we're gonna keep we're gonna keep dividing it by 1000 and keep an eye on I, like keep incrementing the I. Mm, If it is not completely divisible by 1000, we're gonna make sure we do we do two things. The word is gonna become equal to. We're gonna use a helper function in order to uh, uh, like calculate anything less than like 100. Sorry, anything. So we take the modulus of that and we send it to the helper function, and the helper function is basically gonna be uh, looking for two things. One is the like what's the like where does it stand for anything less than 20 and anything less than tens, and like basically it's gonna go through all of it, and then it's gonna go through all of these variables and see uh, which ones we're gonna be using, right? That helper function is gonna just give you for the first 1000. So we'll say we're gonna once it comes out, we're gonna make use of this thousands of I plus, we're gonna put some space in it, and plus the words. So every single time what we are trying to do is to process it, but in the end we are actually appending the new strings at the beginning. So we process the first 1000 and then divide it by 1000, right? And then just remove that last least three least significant bits, and then we process the uh, next three significant bits, and then significant digits, and then that's how we keep doing it until it becomes equals to less than 0, equals or less than 0. So the last thing we want to do is to implement that function public string helper and num. Okay, so for that, the base condition is going to be if the num becomes equal to 0. That is the case, just return empty string. If it is not, but the number is less than 20, then we're gonna, oops, then we're gonna be just returning this less than 20 array, and like array num plus some empty space, plus a space. So we're gonna append a space at the end. Else, if the num is less than 100, so we're gonna be recursively calling this helper function for that. First thing we're gonna be doing is return tens of num divided by 10 plus a space plus the helper function for the num modulus 100. Oh, sorry, 10. And the last thing we're gonna do exactly the same for the thousands. Else, for that we're gonna say return less than 20 num divided by 100 plus 100 plus helper function num modulus 100. So basically we are processing two things here. One is like less than 20 and less than 100. So only two of these final string arrays are used in the helper function, less than 20 and tens. All the thousands processing is done in the main loop. Okay, let's give it a try. So we are missing a space somewhere. I think the space is missing over here. Looking good so far. And it works.